Google stunned the world by announcing the development of an AI model 10 times better than the GPT-4. The tech sector and language enthusiasts are awestruck and eagerly awaiting this development. But how much progress has Google made? Is Google planning to make a lasting change? If you're a tech enthusiast who wants to stay updated on the newest advances in AI, this video is a must-watch. So, what's the buzz about? Recently, Google unveiled PaLM 2, its newest AI language model and a challenger to systems like OpenAI's GPT-4. The name PaLM refers to the Pathways language model, while Pathways is a machine learning method developed at Google. PaLM 2 follows up on the original PaLM, which Google announced in April 2022. PaLM 2 is a family of large language models that does next word prediction, which generates the most likely text in response to prompt input from humans. Google claims that PaLM 2 can conduct reasoning, code generation, and multilingual translation, and that it supports over 100 different languages. During his keynote address at Google I/O 2023, Google CEO Sundar Pichai stated that PaLM 2 is available in 4 sizes: Gecko, Otter, Bison, and Unicorn. The smallest, Gecko, is said to be able to function on a mobile device. PaLM 2 is the engine driving the AI functionality in Docs, Sheets, Slides, and Bard. What can we expect from this new development? Let's take a look. Additionally, Google has modified PaLM 2 to perform specific functions for enterprise clients. A variant of PaLM named MedPaLM 2 that was trained on health data can provide expert-level responses to questions like those on the U.S. medical license examination. SecPaLM 2, a different version that has been trained on cybersecurity data, can explain the behavior of suspected dangerous scripts and assist in detecting code hazards. Google already uses PaLM 2 to power 25 features and products on its website, including Bard, an experimental chatbot. According to Google, the most portable version of PaLM 2, known as Gecko, is small enough to run on portable devices and processes about 20 tokens per second, or roughly 16 or 17 words. Using language models locally can improve privacy and provide other benefits, and running these models in the cloud can be expensive. Therefore, reducing the size of language models has significant significance. All that is fine, but how does PaLM 2 stack up to GPT-4? Is PaLM 2 the game-changer Google hopes it will be? And more importantly, with so many similar capabilities, how is PaLM 2 different from OpenAI's GPT-4? According to the PaLM 2 technical report, PaLM 2 outperforms GPT-4 on some translation, mathematics, and reasoning tasks. PaLM 2 has a ton of new and enhanced features over its predecessor. The fact that PaLM 2 is available in smaller sizes, specifically for some applications with less powerful onboard computing capability, is one of its special advantages over GPT-4. According to Google's 91-page PaLM 2 research paper, PaLM 2 is also more skilled at math. However, it is challenging to directly compare the two models because of how Google and OpenAI structured their test findings. The PaLM 2L is the largest model in the PaLM 2 family. While its actual size is unknown, we do know that it is substantially smaller than the largest PaLM model yet requires more training. Thus, this raises the important question: how large is PaLM 2 in terms of parameter count? PaLM has 540 billion parameters. Therefore, significantly smaller should put PaLM 2 at between 10 and 300 billion parameters. What main differences exist in the training data from the GPT-4 and PaLM 2? Google says in its research paper that the new LLM's training dataset is substantially bigger, even though the company hasn't disclosed the size of PaLM 2's training dataset. This has irritated some industry professionals who frequently advocate for greater transparency in what makes AI models tick. That isn't the only feature in PaLM 2 that Google has kept silent about. The company claims that PaLM 2 was trained on a diverse set of resources: web documents, books, code, mathematics, and conversational data. but does not specify that data. The PaLM-2 dataset, like other big language model datasets, is likely to contain a wide range of copyrighted information used without permission and potentially hazardous material scraped from the internet. Some experts have been promoting the usage of open datasets that can offer prospects for scientific reproducibility and ethical scrutiny because training data significantly influences the output of any AI model. Despite a tendency in all LLMs to just make things up out of empty air, criticism of withholding its secret sauce hasn't stopped Google from pursuing the extensive deployment of AI models. During Google I/O, company executives demonstrated AI features in many of its major products, implying that many of the public may soon be confronted with AI confabulations. When introducing GPT-4, OpenAI followed a similar strategy and avoided mentioning the size of the training dataset. However, Google sought to concentrate on a deeper knowledge of science, logic, reasoning, and mathematics. As a result, a sizable portion of PaLM-2's training material pays attention to these subjects. According to Google, PaLM-2 has improved in all areas, at least when compared to PaLM, because its pre-training corpus is made up of data from a variety of sources, including web publications, books, code, mathematics, and conversational data. PaLM-2's conversational skills should also be on another level, given that the model has been trained in over 100 languages to improve contextual awareness and translation capabilities. When you ask GPT-4 a question, it can generate a wide range of responses, not all of which will be relevant to your query. OpenAI fine-tuned the model's behavior by combining reinforcement learning with human feedback to align it with the user's purpose. While we don't know the actual training data used by any of these models, we know that the training objective was substantially different. We'll have to wait and observe how this difference in training intent differentiates the two methods in practice. PaLM-2 and GPT-4 are accessible via their respective chatbots, Bard and ChatGPT. Bard is free to use internationally. However, ChatGPT Plus, which includes GPT-4, is not. GPT-4, on the other hand, is available for free through Microsoft's Bing AI Chat, which employs the model. Because PaLM-2 is an open-source paradigm, this accessibility plays a role in its potential adoption. Google has included PaLM-2 in over 25 of its products, including Android and YouTube, while Microsoft has included AI features in its Office suite and numerous services. Although GPT-4 has garnered popularity among developers and startups due to its early release and improvement, the open-source nature of PaLM-2 could be attractive to a wider range of users. PaLM-2 significantly improves Google's LLM, but does this mean it can now compete with OpenAI's GPT-4? Since PaLM-2 is still in its early stages, it's unclear whether it can compete with GPT-4. However, with everything Google is promising and the aggressive method in which it has opted for propagating it, it appears like PaLM-2 can give GPT-4 a run for its money. However, GPT-4 is still a strong model that, as previously stated, outperforms PaLM-2 in several comparisons. However, PaLM-2's numerous smaller models offer it an evident advantage. Gecko is so light that it can run on mobile devices even when they are not connected to the internet. This means PaLM-2 can support a new class of products and devices that would otherwise struggle to use GPT-4. The race for AI supremacy has become more intense with the release of PaLM-2 and Google's continuous development of the multimodal AI model Gemini. Google's dedication to advancing AI technologies shows a persistent nature to innovate and outperform market leaders like GPT-4. The future will reveal how these language models evolve and shape the landscape of natural language processing and artificial intelligence. That's all we've got for today, guys. We hope you enjoyed it. Thanks for hanging in there till the end. We'll see you in the next video.